Hello everyone and welcome to the code walkthrough for the Hexaleaf video. If you haven't watched that, then I don't think you'll have much enjoyment from watching this video. I will assume that you have watched the entire Hexaleaf video and this will just be the code walkthrough for that video. There's quite a bit of code here. I will assume that you know basic C or at least how to program Arduino at least. Fun fact, I am sitting in our new apartment and the echo in my room is extreme as there is no furniture here yet, so I'm sitting covered by a blanket. The entire computer screen and myself is just covered in a blanket, so yeah, you can envision that if you get bored. So, the first thing you'll be noticing is that I'm not editing within the Arduino IDE or the Arduino code editor. I like Visual Code a lot more. If you want to use another editor, you open your Arduino software, you enter preferences, and then you press the Use External Editor checkbox, which is kind of handy if you're like me and you prefer to have some nice extensions like code completion or Vim mode as I use. So the first thing you're gonna notice if you open the GitHub for this project is that the project contains two files, and the reason for this is just that I want to separate the different parts of it a bit more to make it more readable, I guess, and also more easy to explain. The basic project or the base project, the base file is a better word maybe, is the hexalite.ino or ino. This is where you find the setup function and the loop function that we're so familiar with from all Arduino programs. Okay, so as I said in the video, we're using an ESP32 and that has a functionality for Wi-Fi, which is required for this project as we're using the Blink app to control the lights with the app. This app is really handy. I will not go in detail about how the app works itself, but the little I will say about it is that it allows you to create a function whenever something is changed in the app. So for instance, if you change a slider, it will call this blink right v1 function, where the value of the slider is passed in the v1 variable. So for instance, you have a slider that goes from 0 to maybe 255, then the v1 value will get the value from the app, and you can use that to whatever you want to do, like set a color or a brightness or anything really, which is really handy, and it's a great tool, I guess is what I want to say. It's a great tool to use, and it's very easy to set up new functionalities. It does cost a little bit of money if you add a lot of functionality, but the very basics are free as far as I know. So that's that. That was a bit of an introduction, or was it? I think I'm suffocating under the carpet, but here we go. At the top we specify the password and the SSID of the Wi-Fi networks, as well as the authentication token of the Blink app. That's something you get when you register a new app on the app. You have to use this to be able to control your app, else it won't be able to distinguish between you and any other user, so that you will actually be able to control your lights. In the setup function, all we do is to start a Blink session. We also start a new NanoHex session, which is something I made. We will cover that soon. That's what we find in the nanohex.h. Moving on to the loop. In the loop you can see we only call the Blink run and we only call the hex controller update. So the reason to not, well, I guess I should say this about Blink is that you don't want to introduce a lot of delays. So you can't do like delay for a certain amount of time. It will cause a lot of delays. It will cause a lot of problems with the Wi-Fi network. The Wi-Fi has to run continuously to be able to handle packets and stuff, so you should never use delays with Blink. There are ways you can kind of hack delays, but I have tried not to use any of that thing. We're just using timers to be able to time the LED lights and to be able to create different patterns. So the architecture is actually, I wouldn't say it's complex, but it might seem a bit overkill for such a simple program. I find that creating a proper foundation makes it more fun to come back and update the project, because then you have a better groundwork to work with and you don't have to struggle as much with the code. So that's why this may seem a bit overkill for the little functionality that we have. So we have 3 modes of operation. As I told you in the video, we have the static fading, we have the what I called it the binary twinkle or something, twinkle binary or twinkle secondary primary, and then we have the twinkle hue. So I like these colors, I like these settings a lot, that's why I chose them. The fading, oh sorry, static color. The static color is obvious, you just choose the color that you want and it will be that color. The twinkle, the binary twinkle will randomly fade each of the lamps in between 2 colors. They will be asynchronous with each other, so some lights might be green, some might be blue if those are the 2 colors you chose, and they will do so at a different pace. So I have made this class called NanoHex, which is the base class that controls everything. And we're going to move over to the nanox.h. Just before we do that, I want to show you that we create just one object of that hex controller, so that is a simpleton. And we also don't do a lot to it. We set the mode on that object. We also do some other stuff, setting different colors, and we also set the fade time and the randomness. We might get back to that, but the thing that's most important is that we call the update function every time the loop runs. So that's kind of important. That's what makes all the colors update. But we'll see that when we move over to the nanox.h. So this is a kind of large file. You have to set up settings at the top here, which you need to specify for your own project, at least these 3. It needs to know the amount of LEDs in each box, and that's actually not entirely correct, because it's not the amount of LEDs but the amount of addressable units. So some LED strips have three LEDs per addressable unit, so when you access LED number 0, actually you're controlling 3 different diodes after one another, of course. And the amount of boxes you have, and finally the LED pin, which is the pin that you decided to control your LED strip from. Okay, so in this file we have 2 classes. We have the hex node, and then we have the nanohex class. The nanohex class is what we saw in the main file, and this is the controller class or object that will control all our LEDs. So there's a lot of helper functions down here. They are all pretty self-explanatory. I think I will talk more about the main architecture itself rather than discussing every single little function. You have a lot of variables, helper variables. The most important one here is the nodes, of course, because those are, each node is each lamp basically. You also need to have the last due timer, the mode timer, yeah. You actually need all these variables, but you might need to add more if you want to add more modes later. So this is the constructor of the function. Here we just set some standard values in the initializer list of the constructor. In the function itself, we only do the fast LED call to set the LEDs. You have seen this in mostly all my videos. We have to set which pin we control the LEDs from, how many LEDs there are, and of course a reference to the array that contains the LEDs. And this should be defined at the top of this top of this file. And here we have it. It is the size of all our LEDs. We compute that just by taking the amount of LEDs in each box and multiply that by the amount of boxes that we have. Alright, so once we have set up the functionality for fast LED, we loop through all the amount of nodes that we have, or the amount of boxes we have, and in our nodes array we specify that each element should contain a new hex node object. Then we can look at the hex node object and what do we actually specify here. So in the hex node object we take the index of the box as the parameter. The index is a number value of the lamp itself. So say that you connected 0, 1, 2, 3 together, then the connection order will determine which index the lamp gets. In the constructor we just compute which LED that starts within the bounds of our box and which LED ends within the bound of our box. This is important to know. So for instance, if you have, say, you have 200 LEDs, or let's make it a simpler number, you have 15 LEDs and you have three boxes, then you need to know that the first 5 is in the first box, the next 5, number 5 to 10, actually 0 to 4, 5 to 9, and then that's in the second box, and then you have 10 to 14 in the third box. So that's basically what this computes. It multiplies by the amount of LEDs in each box to get the start, and then you plus the start with the amount of LEDs in each box to get the interval. Pretty simple stuff. Let's go back to the nanohex object. So, as I said, there's a lot of helper functions here, but update is the function that gets called every second, and that's what we need to notice here. So first I just want to skip this if. We're gonna come back to that soon. We just want to look at this part here. So what this does is it takes the millis function call, millis, it returns the amount of milliseconds basically since the start of the Arduino, I think. So this will wrap around or overflow every something days, and that's not that important for us. So here we take the time and we subtract the time we last drew all the LEDs. Okay, and if that number is larger than the variable draw every nth ms, then we will do the functionality in here. And this is to prevent the LEDs to update every millisecond. We don't need that. The eye will not be able to catch that, and it will simply just be too fast for the ESP32 to be able to do that. So we have a delay, and I set the delay in the constructor, and that is 60 ms. So every 60th millisecond we will update the LEDs. What we do then is we loop through all our boxes which contain hex node object, and on each hex node object we call the function draw, okay? And then we do fast LED show, which is the fast LED function to just visualize whatever color changes has happened since the last time we drew on the LED strip. And then we update the last drew value so that this check will reset and we will only be able to draw the LEDs again after 60 milliseconds. So this function here is, this draw function is called every 60th ms, which is good to know. Okay, so we're just gonna follow that and we're gonna go to the hex node object. So this is now the lamp object itself, or each tile is an hex node object. So let's move down to the draw function. So here we have a lot of different things going on. We're just gonna ignore this part and this part for now, and we're just gonna deal with this. So what we do is that we set the position, the start position of our LEDs that we computed before, and the end position. We loop through from the start position to the end position. We set each of these LEDs to the color of our hex node object. And that is something we have up here. And it's initialized in initializer list, as you can see, to the CRGB object 000, which is black. So whenever you start, it will update the LEDs to a black color, which is off. So the LEDs will be off when you start everything. So as long as color never changes, then the LEDs will be off. That's how basic it is. But we do modify color somewhere around here, and that's when things get a bit more complicated. But we're gonna do the easy part first. So we're gonna jump back to our update function in the Hexaleaf, the nanohex object. And we're gonna talk about this part here, which is what we skipped before. So this is also called every time loop runs in the Eno project. Every time this one here is called hexacontroller update. So every time that runs, we do this check here. So we only want to do this check. This is the same logic as down here. We just check every 3rd second. This is to not spam it. We don't need to do the check all the time. There's no reason for that. But actually, I'm not sure if that's needed anymore. Yeah, feel free to update this code on GitHub if you find it clumsy or not good in any way. I wrote this in a day, so yes, I will accept criticism. So first, we switch on the modes. The mode is set via this blink command. So as you can see, I think up here, blink right pin number V1. Here we get the mode. So this is a mode you can choose from the app. And we have 3 different modes. We have a 1, 2, and 3. And now we're gonna talk about mode number 1. Did I add this? Oh, let's do that. So mode number 1 is mode static color. And let's just move to that function. So mode static color, what it does is just it loops through all our tiles or a number of boxes. Maybe num tiles would be a better macro for this. Yeah, feel free to make a pull request. And for each of the tiles or each of the nodes, we call the set static color, and we apply the primary color. The primary color is a variable we have set in this nanohex object, and the primary color can also be set via the app. As you can see here, primary color, it accepts an RGB value and it sends it into the set primary function, which updates the primary color. The default color is green, bluish, teal, I guess. Yeah, blue with a green hint in it. So, sorry, I fell out a bit. So yeah, we do the set static color on all the objects. Let's just move to that function. So that's simple enough. It sets the pulsing and the animating to false, and then it sets the color to C. And as you remember, the next time draw will be called, this function here, then the LEDs will be set to color, and voila, instantly almost you will have the color of the LEDs being the color that you set in this function. So that's quite easy, and it's yeah, I think it's almost as simple as you can get within this framework. I think it could be nicer. Instead of just instantly setting the color, it could fade, like a very quick fade to that color. I think that would appear smoother. But for now, this is good enough. We're gonna move to the next, sorry, wrong file. We're gonna move to the next function we have, or the next mode. And that's the mode binary twinkle. And this is where things get slightly more complicated. So, as you recall, we had the primary color, which we talked about in the last mode. We also have the secondary color, which can be set via blink in a similar fashion. It accepts an RGB value, so now we have two values stored in this nanohex object. We have the primary color and we have the secondary color. So on all the node objects, just as before, we call the start pulse function instead of the set static color function as we called last time. And this accepts a whole lot of arguments. We have the primary color, we have the secondary color, we have some random value here, which is actually just a static delay, so that whenever a lamp reaches a certain color, it will delay for that amount of time. It's not a lot of time. Then we have some random numbers here, and then we have a 1, and then something called the interrupt. I'm not gonna address these quite yet. Let's just focus on the primary and the secondary. And then we're gonna look at the start pulse function. So the start pulse function will check whether or not we're already pulsing, and if we are forcing an update. So that's what the interrupt was for. If the interrupt is true, then we're gonna force the function to run, no matter what, if it's already pulsing or not. But let's assume nothing is happening, it's not pulsing. Then we call the set color function, which is quite important for everything to work. This is actually the core, one of the core things to quite understand. So this set color function, it sets the color to CRGB color, which is another variable of the object, a member variable. It also starts a couple of timers, the last draw timer and the start draw timer. This is when we started drawing, this is the last time we drew. Then we set the animating to true, and then we compute the fade vector. So bear with me, guys. So we haven't set the color yet, we have just set the color to. The color function, the color variable is what it was before. So this remains unchanged. The color to variable that we have never seen before now has now changed to the color that we want to go to. Okay? Okay, so the compute fade vector function, it modifies the fade vector member variable that we have set before. It's defined here, and it's the type fade vector, which is something I defined up here. I might, at some point I thought I was gonna use the hue, saturation and brightness values. I never did that. That's why this is a union. So it's possible, but currently we're just using the RGB values of this struct or this union. So in the, So in the fade vector, what we do is that we look at the color that we want to go to, and then we subtract the color we're currently at, and then we divide that with the fade time ms, and that gives us a value that we have to add every time. Okay, so say that our color is currently 0. We don't have any color at all, but we want to go to red, completely red. So then we have, of course, completely red is 255. That's the maximum of an 8-bit value. So then we have these two values, and we have to divide that with the fade time in milliseconds. So say we want to fade from 0 to red in 1 second. That's divided by 1000. The result of that is 0.255. That's the result of this computation, and this happens for RG and B. So this is the amount of change we have to do on the R value for each millisecond that has passed. Okay, so whenever 1 millisecond passes, we have to update the R value 255 times. That makes sense, right? That's to go from nothing to a completely red color. So, okay, we have computed the fade vector. That's great. We have set the start draw timer, which is the timer when we started to draw. The last draw timer is set to the same. And then we set animating to true. Okay, let's now move down to the draw function. And then we're gonna look at, we're just gonna ignore the pulsing part for now, just skip right to this, because now this will be true, where it was false before. So we are currently animating, and then we call the function color update. Okay, this is also an important part to understand. Not if you want to do the project yourself, you can just use the framework, but it's an important thing to understand if you want to understand everything completely. So we have the delta ms. This is the current time minus the last time we drew all the LEDs, last time we updated the LEDs. So say that we waited 60 ms. Now we update the last row timer just to make sure that it will be updated for the next time we enter this function. Okay, so now we're going to compute three values, the R, G, and the B. So the R value we have to set is the color that we had before. So the color that we currently are at, so say we were at 0, okay, as I said, then we have to add the fade vector that we computed before. Remember that was, if we scroll up here, that was 0.255. But that had to be done for every millisecond, right? Remember? So we have to multiply that with the delta, because that's how long time has passed since the last time we drew the function. So at this time we would have to do plus 0.255 times 60. So that's how much red we have to add to keep up the pace to reach a full red color within 1 second. I can't do that in my head, so that's 15.3. Yes, this is of course an int, so it will be something like this. So now the red value will be probably 15. Yes, that's just for the first 60 ms. The same thing happens to G, to green and blue. This scary looking thing here is just something called a ternary, which is, this is basically a shorthand if statement. So here you have an expression. So if R is larger or equal to 255, then we have to set the R value to 255. This is just in case something happens that makes the color go a bit out of bounds. We just want to force it back down to 255. Else, if the R value is under 0, which when I'm thinking about this an int. Yeah, okay. So if it's under 0, then set the color value to 0. And if it's between 0 and 255, which is the else here, then just set the color value to be R. So then you update the color itself to be the new value from here. Okay, and what will happen next? The draw function will set the LED's color, and now it will contain our updated color. I skipped this part here. This is just a check to see if we have reached the amount of the fade time. So if the fade time was 1000 milliseconds, as I said before, and we started drawing 1 second ago, then this has been reached. Then when our animation is over, we have to set animating to false, and then we trigger our peak timer. So this is the basic functionality to be able to make a fading effect from a black LED to a completely red LED without using any delays, only using timers in the program. That's what enables this Blink app to work so nicely with the code that we have. I'm gonna talk a little bit about the other two variables that we had in the beginning. When we set the start pulse function, we also accept the p delay, the p speed. The p speed is the interesting part here. So that's the fade time that we're gonna the time we're gonna spend fading from for instance 0 to red, from black to red, how long time is that gonna take? It's gonna be 1 second, it's gonna be 10 seconds. But if we go back to the mode binary twinkle, you remember that that was actually a random value. So we have the fade time min and the fade time max. So for each of the boxes, we compute a random value, which is from maybe, let's say from 1000, so 1 second, to 6000, then 6 seconds. Then each lamp or tile will have a chance to do the fade in 1 second, or in 6 seconds, or in 3 seconds, or in 4 seconds, or in 4.5 seconds. And this will create a nice organic look. They will not be synchronous, they will be kind of offbeat and fade at different paces and create a kind of interesting look, I think. Remember that they will fade between the primary and the secondary color. A nice effect is to set the secondary color to black, so then just each color will fade in and out. That's a kind of neat trick, I think. This one here is just how many times the fade is going to happen before animation is set back to false. I haven't really used that yet, but I added the option for it. I thought I was going to use it. Yeah. The interrupt is if we have a new color. For instance, a new color is coming in. We set the primary color from here. We get a value from blink. The color is coming in. Let's see here. We call the set primary. Then we set the primary color and we set the interrupt to true. We also reset the mode timer so that the update will come in instantly. When the interrupt is set to true, we will just force a color update instantly. We won't wait for the animation to finish or the polls to finish. So that's it for the binary twinkle. The mode hue twinkle is actually super similar. It's almost actually that's part of why I wanted to make this framework. When we created the hue twinkle, it was almost no job at all compared to the binary twinkle. Yes, so this might seem complex, and maybe it is, but it would be nice to see if you have any interest or any skill with code. Maybe try to add a couple of features. I will for sure look at pull requests, and if they're nice, I will accept them, and I can also test them on my lights and put them out on Instagram if you want to see your effects on my wall. I think that would be kind of cool. But let's go through the hue twinkle. Okay, so this is taking advantage of some features in fast LED. So we have this function called RGB to HSV. If you don't know what HSV is, it's basically if you've used Photoshop. I can open the Photoshop and show you kind of easily. Okay, let's take the thumbnail for the video. So whenever you color pick a color, you can see over here, you can see the RGB value. So here the R value on the blue, the R value is low, the green and the blue is pretty high. The HSV is the hue, saturation and the brightness, and you can see if we change the saturation, the colors will become brighter or they will become more faded, more black and white. So this is 0 saturation, max saturation. The hue is the color, so if you change the hue, the color also changes, right? The lightness is exactly what it sounds like, it's black or white. So moving back to our code, originally we used the RGB values, but it's a lot easier to create, to know how to change color within the color spectrum or within the same area of color using HSV, using the hue value basically. If you have blue, you know that if you add say 10 to the blue value, if you have a hue that is blue and you know that you add the 10 to the blue value, you will have a different color, but it will be in the same color spectrum area as the blue one. So it will be a slightly different blue color, maybe bordering to green. But that's what makes an interesting effect, I think, to be able to randomize the hue a little bit. So not go all crazy on the colors, but to stay in the same area of color, but maybe with a slight variation. So we do a conversion. We convert the primary color that we already have from an RGB value to an hue saturation value. And here we compute two colors. So basically what we're doing, we're taking the hue value that we already have. So the hue value of the color that we're already using up here. So say that we have blue, then we have a hue of, I have no clue, but say blue is 80. So then we have a hue of 80. And then we take a random value from the hue randomness. This is also something you can set via the app. But say that the hue value randomness is, now the hue value randomness is 40, okay? So blue is 40 and randomness is, blue is 80, the randomness is 40. Okay, so now we take a random value from minus 20 to 20. Okay, and we add that value. So say any number between minus 20 and 20. Okay, say minus 10. Then we take our blue value and we add minus 10, and that is 70. Okay, so now we have a slightly different color. It may not be blue anymore, but it may border to purple. And then we set that color to color 2. And we do the same for color 1. So maybe color 1 will be, maybe it's blue again, or maybe it's slightly green. But we will start a pulse and it will go from color 1 to color 2. So if you have a hue that's blue, if you have a primary color that's blue, you will have pulses that start and stop in the same color spectrum area as your original color. Of course, depending on the hue randomness. If you go all crazy on the hue randomness and you set that to 255, you will see colors of the entire color spectrum, and that's cool too. You know, you will have completely random colors appearing randomly on the tiles. Yes, those are the 3 different modes I have created, and I think I've spent almost 40 minutes or more talking about this so far. I wish I could go more in detail on it, but to be honest, you just have to look at it yourself. And if you have any questions, feel free to post it on this video. I will answer them as good as I can. You can post them as a comment. You can also message me. But if you post them as a comment, people might answer for you, for me, sorry, if I am slow. I'll try to be as fast as I can. And as I said, feel free to create pull requests if you want to see this code improve. I really enjoyed making it. I wish I had time to make more code projects like this. There's something about LED lights. I think they're so easy to program, and that's my appeal with them. So I like the lights, of course, but just to be able to write some really interesting code that has such nice implications for the LEDs. I don't know. It's just interesting to me. Anyway. Yes, so thank you so much for listening to me. I hope I made some sense. If I didn't, then please let me know and I will try to improve it to the next time. Thank you very much. Bye bye.